So today we have Michael Larabel. Michael is the founder of Phoronix.com that he started in 2004 for covering Linux hardware and has continued since. Michael is also the lead developer of the Phoronix Test Suite and openbenchmarking.org for advancing open source benchmarking and offering a robust collection of test cases and real-world benchmarks. Mike, welcome.
Thank you, Dennis. Glad to be here.
Thanks for finding time. I really do appreciate that. And just to begin with, right? I want to say that actually I used Phoronix Test Suite multiple times, and especially when I was looking for examples for my book and for performance challenges that I organized in the past. And so I remember I ended up using at least one of those benchmarks. It was I think I took X264 benchmark for my book. So yeah, thanks for doing that. I really appreciate that you have put a lot of efforts into make it open and available for free for everyone to use. Yeah, thank you for that.
Certainly, it's been definitely a passion of mine.
Yeah. Well, and that's actually, I'm a performance guy, right? And I'm mostly interested in this, in your performance benchmarking suite, right? But I know that your small empire is more than just Phoronix benchmark suite. So, before going into all this benchmarking stuff, can you briefly give us an overview of what are your other, projects?
Sure thing. So yeah, obviously in 2004, I started Phoronix.com for reviewing Linux hardware. Since back then, issues with 56K modems, mice, and basically other peripherals that we now take for granted working nicely on Linux. Back then, it was much more of a headache, especially with devices like graphics cards being notoriously bad back then. So I started Phoronix writing there to detail how different hardware components were working under Linux. And then obviously, like all the other Elbit-based review websites out there, I needed a means to be able to test all of these different components under Linux. And that's basically how the Phoronix Test Suite was born, for being able to satisfy my personal needs. But unlike many of the other websites out there that have scripts and everything they all keep internally for their benchmarking, with the Phoronix Test Suite, it's all open. So contributions from the community are welcome, and satisfying more test cases than just my personal needs for Phoronix.com. And from there, that's basically grown. And as part of the Phoronix Test Suite is also openbenchmarking.org, that serves as like the cloud or central repository where users can opt to publish the results in the centralized location and easily compare benchmarks between different parties, as well as versioning all the test profiles and making them available via openbenchmarking.org, so users can have immediate access to new versions of existing tests, as well as new benchmarks in general as they become available.
Yeah, that is wonderful. It like in 2 years it will be 20-year anniversary for Phoronix, right? I started programming in 2007, so so yeah, that's really amazing and wonderful. But why start why starting new benchmark suite? So when you started Phoronix benchmarking suite, what was the year that you created this?
The version 1.0 came out in 2007, but prior to that, back in 2004 is when I started benchmarking different hardware. And from there, basically, it started out as a collection of bash scripts for just executing different time demos and timing various commands, etc., for carrying out the benchmarks. Then from there, basically grew organically to satisfy the needs for running Phoronix.com and adapting as hardware became more powerful. And then obviously in the years that passed with OpenCL and GPU accelerators, etc., just growing to meet those different benchmark challenges.
Mm-hmm. So I wonder, at the time when you started, Phoronix benchmarking suite, how many other benchmark suites already existed at the time?
Well, because the Phoronix Test Suite itself is more of a framework for conducting the benchmarks, there really isn't any other framework per se in terms of the same scope of the Phoronix Test Suite for making it easy and repeatable to run a wide variety of different software under test. Um, so there, yeah, really wasn't an alternative back then for basically conducting these tests in an automated way, short of writing your own, or yeah, all these different companies also having their own internal test suites, but nothing that's publicly available and has a large breadth of different benchmarks.
Okay, let's talk about how Phoronix and where Phoronix Test Suite stands right now, right? Because okay, we have. And what are the other benchmarks besides Phoronix? Well, Phoronix is obviously the best, but what others do we have?
For example, somewhat related to and another example would be Intel does have some with their kernel test robot, as basically a collection of scripts that they use for testing the Linux kernel on a routine basis. From there, they can run different benchmarks, including the Phoronix Test Suite benchmarks. So that would be another similar alternative.
Mm-hmm. Okay, yeah, but so if we compare, for example, Phoronix Test Suite with other industry benchmarks, like for example spec like has this multiple components, right? Then spec CPU, and then I'm mostly from the CPU world, so there in CPUs benchmarking, there are other, of course, benchmarks like what else we have? We have Geekbench, we have
So
we
yeah.
have those pass marks and so on. Yeah. So how it compares, to Phoronix Test Suite?
Right, so like the spec CPU or spec JBB and all the other spec benchmarks are, yeah, great for having an industry standard defined benchmark. But it's sort of a different scope than what the Phoronix Test Suite is, where with spec there's a whole set of processes involved for basically adding new benchmarks. Like they don't add new workloads and everything in a rapid and as they become available manner. So yeah, spec is great for coming up with an industry standard where, hey, you can compare your spec CPU number for performance. But yeah, the Phoronix Test Suite itself doesn't just provide one number or a set of aggregate numbers. It's more about being open and allowing a wide range of benchmarks to be conducted. Like with the Phoronix Test Suite, you can carry out spec CPU or spec JBB, and some of the others as a benchmark component. But yeah, it's sort of a different aspect. Basically, spec and the Phoronix Test Suite can work like concurrently. Mostly it's Phoronix Test Suite's about test automation and wrapping around existing software programs or benchmarks for facilitating those, and then aggregating or collecting all the benchmark results and presenting them in a unified manner, and archiving them as well in a standardized fashion.
So do I understand correctly that in theory you can hook spec CPU and and integrate it into the Phoronix Test Suite, right?
All right. So yeah, there's over 600 different workloads or test profiles, as I call them, available via the Phoronix Test Suite for execution. And it's up to the user to decide which benchmarks they may be interested in, whether it's X264, X265, or something like spec CPU, or SVT, AV1 video encoding, or time code compilation of different code bases, etc.
Yeah, wonderful. But and actually, I wonder what are the business models when you are creating and making the benchmarks. Like, okay, so I understand that like you don't write benchmarks yourself, but like if we talk about this business models, like for example, spec CPU is a closed, right? So you have to pay a license fee to get the access to the source code, and it's not cheap, right? It's I guess it's $1,000, something like that. So it's not like that accessible to every person. like regular person, right?
Right.
But on the other hand, as far as I understand, they are not even looking to grow their sales per se, right? So they are not like making it commercial product, right? So they are it's an organization that is getting financed from other from elsewhere, right? Not just by selling those licenses, but also we have other companies that are directly writing the code themselves and selling this access. So what are your business models? Have you not yours maybe particular, but what are the business models and how you can make money with creating those benchmarks? And have you ever thought about that?
Right. So yeah, from my personal perspective, it's basically fulfilling the needs of what I need to do to run my benchmarks for Phoronix.com. So it's largely driven in that manner. And then in the past have done some consulting and other custom work. But yeah, obviously, yeah, Spec is a great organization for getting all the industry vendors together to come up with a defined set of benchmarks. And yeah, unfortunately, yeah, their costs are rather high for aside from the few benchmarks they have available that are free for personal use. But then there's also software out there like Mark or 3D Mark on Windows and a number of other synthetic or semi-real world benchmarks that are strictly going after sales volume and selling higher priced software for the industry ISVs and IHVs to make use of. And then just the traditional proprietary software out there that happens to have a benchmark mode, but in many cases, it's those software vendors that are simply having those benchmarks because they use them internally and then keeping them within the production build as opposed to focusing their software for benchmarking purposes.
Mm-hmm. Yeah, and understood. And then, just wanted to say again, thank you for making it open and available for everybody to use for free. I definitely appreciate the spirit of open source and you following. So that's again huge thank you. But so. And by the way, it is fully open source, right? So the sources for the benchmarking suite and the Phoronmatic, right? Is that the engine that's driving it fully automated, right?
Right. So it's all open source under the GPL v2, and then it's for the individual test profiles. Those are all open. But say like in the case of spec CPU, that test profile won't work unless you happen to have the available spec ISO already on your computer. Similarly, for some of the other like closed source games that you have to have own a copy on Steam, that the Phoronix Test Suite is simply automating those tasks. But for those select components, if you don't happen to own that given software, the benchmark simply won't run. But yeah, out of the 670 or so different benchmarks, I would say less than like 100 of them are proprietary or commercial software.
Mm-hmm. Oh yeah. So if we can go back actually, to the spec CPU, for example, right? So do you maybe have the perspective of like what is your audience as compared, for example, with spec CPU? Because spec CPU is widely used in sort of academic area, right? So people are usually when they're writing their papers, they usually use spec CPU. So do you know what are those people that are actually running Phoronix benchmark suite? So do you know like are those gamers? Are those just people that are looking to buy a new CPU, or are just those people that are for example just interested in, I don't know, maybe video compression, like in general?
Right. I would say it's a fairly general mix of many different audiences. There's software and hardware vendors running the Phoronix Test Suite internally because of its wide range of software that can be benchmarked and the full automation. So they're able to test their hardware software components on of just a wide range of software to ensure there's no performance or functionality regressions. But then like with Phoronix.com, many of the benchmarks I'm running there for hardware reviews are more focused on common workloads, letting readers know how fast with a new CPU they can build the Linux kernel or encode a given video file, and trying to aim for more real world performance comparisons with tasks like code compilation or video encoding or gaming performance, etc., that are more representative than just a spec CPU score. And there's also some people running Phoronix Test Suite that are very interested in, say, uh, PJSIP or QuantLib, like some of these specialty libraries, or like some of the CAD programs where there are benchmarks available in the Phoronix Test Suite that are either developers for those programs or just heavy users and wanting to just benchmark their CPUs with them to compare against my public data. So it's just a fairly wide mix of different use cases.
Great, and Phoronix Test Suite is highly successful, right? So can you just give some numbers?
Sure. So it's used by a wide variety of IHVs and ISVs in terms of like the openbenchmarking.org numbers. Let me pull it up currently. So the latest data. There's been over 51 million downloads from openbenchmarking.org to the Phoronix Test Suite client of different tests and test suites, which are a collection of test profiles. There's been more than 2.3 million systems that have connected to openbenchmarking.org for collaborating with uploading results and other comparison features. 678 different unique tests available, and if you were to run every one of them, it would take about 37 days to complete.
Jeez. I mean, that's great. Really, congratulations. That's a huge success, I believe.
Thanks.
Talking from the basement from your lab.
Yep.
Yeah, so sorry about that, but I was just, I was just watching like one of the YouTube videos and with you, and then I was, I was really amazed at how much hardware do you have in your basement, like, well, yeah, that's really that's really great. And by the way, how quiet, there is no background noise when you talk, so that's really interesting.
Well, that's only intentionally that I power off some servers beforehand and then try to work my testing schedule. And thankfully, with this call on a Sunday, it's much easier to power down things that or not have active benchmarks going compared to during the week.
Right. Yeah. Then I also wanted to ask. So how much percentage of all the benchmark scores that you publish, are produced by you? How many scores actually people do send to you? Like they can report, right, the scores to your website.
Right. So when they're completed with their benchmark runs, they can opt or not to upload them to openbenchmarking.org. Um, there is a healthy number of people that are doing that, like say from the community. I don't have any like percentage breakdown though. Obviously, yes, I am running a ton of the benchmarks. But yeah, so like of the 2.3 million systems, over 2.1 million probably are the community.
Oh wow, that's interesting. Okay, let me see. Oh yeah, so I actually was I wanted to ask this question. So like when I, for example, am interested in running, some tests. So like, do I have to make any kind of preparations to my system? Do I have to set up it, properly somehow, or Phoronix takes care of that?
Given the wide range of benchmarks available and the different use cases, the Phoronix Test Suite by default will basically run in the state you have the system in. Since there's people that are comparing hardware, or there's also people that are comparing revisions to, say, running the latest packages for their given operating system on a daily basis. And so by default, the Phoronix Test Suite really isn't trying to change the system state, since you may be running benchmarks for all sorts of different purposes. It will provide some when you start running it at first, like if it sees you're running on like an on-demand or power save CPU frequency scaling governor, that it'll say, hey, in case you don't know, the performance governor may offer you better performance. But yeah, by default, the Phoronix Test Suite doesn't enforce any policies or trying to modify the system state behind your back, since it doesn't know what you are trying to compare necessarily.
Mm-hmm. Chad in the Discord chat wants to know about your latest ARM server results. I mean, probably latest ARM's server benchmarking results.
The latest one that I've done has been with Ampere Ultra Max with their 128 core ARM v8 CPUs per socket. Which is he wondering about just the performance or my thoughts on it, or?
Actually, he is in the room. Maybe he can just ask for for the mic and ask the question. Chad, you wanna do that? Or you can type in the Discord, fine with me as well. Oh, he's typing. He said everything.
So in terms of Ampere Ultra Max that was released towards the end of last year, yeah, it's been a very nice platform. Um, it's wonderful with ARM server ready, how these days you can have a 64-bit Linux distribution for ARM that can boot, and you don't have to worry about any custom kernels or a lot of other modifications. So that's really nice to see in terms of the ecosystem maturing, where yes, our 64 distributions are running nicely. In terms of performance, the performance has generally been great. There still is software ecosystem challenges though around ARM v8. I'd say many open source projects these days at least have like ARM Neon optimizations, but I still routinely come across different workloads that aren't too well optimized. But if the given code bases you're interested in are tuned well for ARM v8, these the latest hardware, yeah, like Ultramax does perform extremely well. And yeah, Ampere has their next generation processor supposed to be coming out later this year. So they can perform yeah, very competitively against the latest x86 64 servers in the right workloads.
Okay, thank you. Um, okay, let's go back to the Phoronix Test Suite, and I wanted to ask, so what components does it have? Like, so what kind of tests you have in Phoronix benchmarking suite?
So of the 600 plus tests, it's a wide range of real world and synthetic benchmarks. So there's more of the synthetic types like CoreMark or SecureMark that many of the CPU guys may be used to measuring code compilation speeds for popular code bases like Node.js and the Linux kernel and LLVM. And then popular software packages like Blender, um, X265, the Davi, the AV1 decoder, and programs like LibreOffice and Raw Therapy and Darktable and GIMP. It's very diverse mix of programs. Mostly whatever I come across that would be of interest or of use to my audience for Phoronix.com to see when I'm running CPU or GPU or other system benchmarks for trying to find software that is in use by my readers and is benchmark friendly. So yeah, it's a very wide mix of software.
Mm-hmm. Right, but so most of your tests are actually open sourced, right? So this is an open source software or some kind of a project, right? This is widely used in the industry, right? And
Right.
mm-hmm. And so you just provide those automation like around that software, right? So in an automated way to benchmark it. Is that correct?
Right. So it's mostly test automation for being able to automate it. Plus, there's other features like being able to automatically monitor the CPU temperatures and system power consumption and other system sensors during the benchmarking process on a per test basis, and or also triggering Linux's perf to run for each time a benchmark's run and record those figures. So yeah, it ultimately comes down to an automation framework.
Great. Yeah. So I wonder, so what, seeing, any kind of performance regressions or maybe even functional regressions. So have you ever maybe, I don't know, for example, captured some some bug that was, recently introduced by Linux kernel or by maybe GCC compiler or anything like that?
Yes, over the years, yeah, unfortunately, I've come across many different performance regressions, particularly in the Linux kernel. There's sadly too often. I don't know. I'd say a couple times a year. I usually find different new performance regressions in the latest Linux kernel tree after a merge window. Or in more recent years, there's also been a number of power management regressions becoming rather common. And still to this day, it seems many kernel developers don't either monitor or test with power consumption for being able to properly calculate the power efficiency or in spotting any regressions. Yeah, so there's been a number of different cases over the years, but at least in the past few years, it's been in better shape thanks to like Intel's kernel test robot and more hardware vendors taking Linux seriously, especially for HPC computing and AI, and all these other areas where Linux is dominating, that they're in turn testing more on Linux and making sure things work nicely.
But I wonder, so what do you do if you see a spike in performance? Like, so, what are your actions?
For a spike in performance, I'm usually happy. In those cases, it's usually explained by looking at the changelog or the pull request for the Linux kernel merge window for whether it's for performance improvement in, say, the AMD graphics driver or Intel's CPU FRAC or other common areas. So when I see the performance go up, it's usually, yeah, explained because the developers intentionally try to optimize the performance most often. But then when the performance regresses in a negative manner, it's if it's severe enough, then yeah, I'll go through and run all the kernel bisecting to figure out the troublesome commit.
Wow, nice. But so and how often actually do you go deep down in your analysis, like and maybe in general, this question, like, so how deeply you analyze the performance maybe of your benchmarks?
It all comes down to how severe the performance impact is. Since obviously my funding comes from Phoronix.com with ad impressions. So if there's some interesting regression and it will get a lot of traffic, then I'll obviously spend more time looking at it. And so then that's where I'll go through the process of bisecting it. And it's also a time matter at that point where if I can reproduce a regression on a 256 core server, I'm much more likely to bisect it and dig deeper into it simply because it takes a lot less longer for conducting the kernel builds. Um, so yeah, all comes down to each particular time that there is a regression. But if it's yeah, I'd say like 10% or more, then I'll usually dive deeper into it.
Again, a question from Chad in the Discord. What are your favorites of favorite affordable pre-built servers for large compilations? 1,000 price point, 2,000 price point?
Is he looking for like a if it's for a totally pre-built server, I don't have much perspective or value to add since most of the time I'm looking at individual like server processors. Um, so yeah, and then yeah, for most of the servers that I'm testing, I'm either using reference server platforms from the hardware vendors or assembling the servers on my own, just with the motherboard, etc. So yeah, if it's in terms of pre-built server, not much input that I can add.
Okay, thanks. Chad is typing probably the question. I will give him maybe a few seconds to finish. Otherwise, I will continue. Um, also asking favorite motherboard then.
If it's for conventional server platform, Supermicro obviously makes good motherboards. ASRock Rack has been a favorite of mine recently because they offer a great selection of fairly affordable motherboards, and I've never actually had a ASRock Rack motherboard die on me, whereas like I've had a number of Supermicro motherboards over the years, or Asus, etc. So yeah, I've been rather impressed by ASRock Rack the past few years for their server motherboards, and that they've been very reliable and on the lower end of the price point, while having all the great features, good BMC interface, etc. Um, and then but you can't go wrong either with Asus, Supermicro, Gigabyte, etc.
All right. Actually, Mike, I wanted to ask. So, going back to my previous question about the about the analysis of your benchmarks, right? So, any kind of performance debugging stories that you can share? Uh, yeah.
Um, Nothing that's too recent or relevant. With the major ones that I've reported in the past year, so they've basically been all corrected upstream since in one manner or another. There's been one surprising anecdote has been up until recently, there has been one major vendor that has blamed their lack of kernel regression testing on the lack of office space, which is a bit odd, but just another growing challenge with Linux. Um, that they can't find the space to set up any sort of lab at all to run routine performance and functionality regression testing. But at least that vendor has since addressed that office space issue. It's just an odd story.
Mhm. Yeah. Oh, and then, by the way, I actually also wanted to ask. So do you buy all the hardware yourself, or there are cases when actually vendors would send you those samples for free?
Right, because of Phoronix.com with publishing Linux hardware reviews. Generally, I get most of the free, particularly the CPUs and GPUs. Um, while some review websites will test out cases and like power supplies and things like that, I'm really just don't have the manpower or too much interest these days in reviewing those kind of peripherals. So I'll end up usually buying those for the given desktops or servers that I'm testing. But in terms of the main components, usually are product review samples.
It's nice. And do you have to give them back?
It all depends on the vendor. Like when I'm testing laptops, I think pretty much every vendor has wanted their laptop back afterwards. But in terms of CPU samples, usually I'm able to hang on to those, especially the vendors like that, because I'm usually testing things later on for new Linux courses and comparing Linux distribution performance and basically a lot more benchmarking compared to some of the many of the Windows review websites where they're doing the products once, and basically even using those old data results with future hardware reviews that they do. Whereas whenever I'm testing say a new processor, I'm always retesting all my processors, given that the open source compilers and the Linux kernel, etc., are all advancing rather well, and it's much easier or much improving on the Linux side, where you can grab a new kernel and a great deal better performance in many cases for the GPU or CPUs. So because of that hardware retesting, it works a lot better having it on hand.
Got it. Yeah. So now I wonder, if there were any those kind of situations when people come and say to you like, "Hey, this benchmark score is not fair," or like, for example, this benchmark is like skewed towards some particular hardware vendor. Did you have any those kind of emails maybe?
Emails and forum posts and tweets. Yeah. Many times, people will be, especially in the open source world, will be very passionate about like their given Linux distribution. So particularly where I'm trying to benchmark a variety of different Linux distributions, and XYZ Linux distribution will come out slower. People will complain that I'm testing everything out of the box. But when everything's in, you can configure everything to your heart's delight. It's really difficult to otherwise test a Linux distribution and be it representative of the users if you have it heavily customized. So that's been probably the main area where people have drawn criticism is testing distributions out of the box, but there really isn't a better way. And I've responded to them that if a given Linux distribution has like an optimized kernel build or some detailed instructions on how users should tune it for the maximum performance, I'm happy to follow those and reproduce the steps. But otherwise, you're basically arbitrarily tuning a box with unlimited potential, given all the open source code at hand, that there isn't rather a fair way of comparing things unless you're doing it out of the box and defaults.
Right, right. No, I mean, I think
Yeah.
in general, I agree with you that that those we should test those those defaults that we are provided with, right? Like
Mhm.
so, and if the particular distribution is not defaulted to high performance, well, then maybe like it's not the primary goal of the distribution, right? And we should use the one that is. Uh, so yeah, I mean, in general, that's a fair point. Um,
Yeah, and then yeah, obviously there will be there's always some readers that have preference for a given hardware vendor. So when they see that a given GPU or CPU loses out on the benchmarks, they'll try to find reasons why it's slower. But to which I encourage them to run benchmarks of their own with the Phoronix Test Suite and see if they can find a different number if they happen to own that same system components under test. But yeah, at least with the Phoronix benchmarks where it's all open source, others can more easily reproduce those tests if you're a reader or a hardware vendor than yeah, other review websites out there where they'll just say they're testing ABC game or 1, 2, 3 workload, but not necessarily provide any insight on all the details or settings files, etc., that are specified with the Phoronix Test Suite and all publicly available as open source.
hmm Got it. But now, so what happens if you say, if say someone has found an issue in any of the benchmarks in Phoronix Test Suite? So do they go and try to submit a pull request in the repo of that particular project, or they can maybe for example, send you a patch that you can then just apply on top of the software in an automated fashion, right? So and then fix the issue in that way.
Right. So it's gone many different ways. Yeah, people have emailed me or posted in the forums or yeah, sometimes submitted pull requests. Like in the case of a patch to apply on top of a given benchmark, like if I have to, I will do that. If it's something for, say, fixing a download link, some people in the past have suggested like including Power9 optimizations for a given program as a patch that's not actually found in the upstream program. So from there, like that's an example of a tricky situation. Like, okay, it may make sense if I'm running an article just looking at the benefits of, say, IBM Power9 optimizations for a given program. But if it's not included in that upstream program, should I really be testing that patched version of the program for some other article where to a reader it may imply then that this given application actually performs very well when it's unless it's patched. So yeah, generally I prefer that the upstream projects um, pull in any significant changes themselves so that the data I'm providing is at least representative of that experience.
hmm Okay, cool, got it. So now actually, so I wonder this. Uh, so how do you and when you add the new benchmarks into the benchmarking suite, so how do you actually determine whether a benchmark really tests what it is intended to test? Because so many times what I have seen actually, well, not many times, but sometimes I saw that there is a benchmark, right? That is, for example, offloading some computation to the GPU, and then of course it is doing that, and the GPU just process this, for example, some image filter, right? It does it asynchronously, right?
Mm-hmm.
But the benchmark And so there is start the timer, then we offload computations using some OpenCL or whatever, and then there is a stop the timer, right? So and the benchmark does not actually measure the GPU activity, right, itself. It just and what ends up measuring is just being the memory copy from the host to device. So that's and the benchmark is like totally wrong, right? It does not measure what it intends to measure. It just measure the mem copy, right? It doesn't measure the processing on the GPU. So did you ever encounter those kind of issues, and then what are you doing to prevent those kind of situations?
Whenever I'm evaluating a new workload to run, I'm testing it on a wide range of hardware in my lab to ensure that, yeah, it's scaling or not, and other factors like that. So yeah, I try to first, before publishing any new benchmarks, to ensure that, yeah, it's behaving as it should and that there's no oddities in the performance across the mix of hardware, including I try to test when my servers are when they are available on 64-bit ARM or even RISC-V and other architectures. So yeah, I basically do some smoke testing that way. Um, but then also I'm trying to add programs or benchmarks that are mature. So ideally, those issues like that would be worked out already by the upstream projects. And then in other cases, like with Blender, where you're measuring like the render time, where obviously it's quite easy to make sure that that makes sense. The number is logical relative to the time it's taking, etc. So yeah, in more recent years, at least, I don't think I've really had any issues on that front.
Well, cool. Yeah, because I can tell from my own perspective, right? So I'm doing this Performance Ninja like small project, which is kind of started as an online course for teaching low level performance. And so I can tell from my own experiences that creating a new benchmark is really hard. It is really hard to write a benchmark that will test and benchmark the thing benchmark.
Right.
Like in the process of creating, you will find many issues, like other kind of bottlenecks that that you like was hoping that will not come up in the real benchmark. So you have to tweak it in multiple ways so that it will really expose the and will stress the thing that you want to stress. So that's really funny. Yeah.
Hmm.
But in general, are you like constantly on the lookout for new emerging workloads and software packages?
Yeah, that's it's pretty much a hobby of mine. Looking at GitHub repos and searching on GitHub and for benchmark, or say like Intel does a pretty good job on publishing white papers and being very detailed in how they are testing software packages. So yeah, I'll read through those whenever I see a new one available, to see if it's an interesting benchmark. Obviously, if like a company like Intel's publishing a white paper using that given workload, then it has some relevance. But then also with my open source news tracking, whenever I see some major new software package that's either very promising or just had a new release, I'll always be looking to see if it added any new benchmark modes or anything that may be interesting for performance testing purposes. So it's a constant battle.
Oh yeah, oh yeah. Okay, so Mike, let's talk about performance benchmarking in general. So what do you think is a good benchmark, and and like what attributes should a good benchmark possess?
Well, in general, at a high level, obviously benchmarks should be reproducible and they should be um, very easy to automate. I would argue that it's any developer or user should be able to easily carry it out in a repeatable fashion. Um, and then there's depends it for a good benchmark in terms of measuring the overall system performance, or if you're looking at more a specialized metric, like say with stress-ng for the Linux kernel, testing of interfaces like that works very well if you're trying to evaluate the kernel performance. But say Blender works really great if you're just caring about system performance. So it really depends upon what good you're looking for. Yeah, if it's for developer ease of use to quickly vet a new kernel, or if you're just trying to find a general system performance metric. But then there's also good benchmark. It can be good in terms of if the source code's very clear and easy to understand. If you're trying to micro optimize the system for performance, that you can very easily analyze things.
Mm-hmm. Yeah, cool. And then, well, so does, when we're talking about good benchmark, right? So does it have to represent the modern day usage? So, like, for example, if we compare, let's say, machine learning popular nowadays, right? But then if we compare it to, for example, maybe data compression. So does it make sense to assign weights in some way to those two different types of benchmarks?
Yeah, certainly these days, given the increasing core counts on systems and servers, not all benchmarks fare the same or scale up to today's high core count servers or even apps. In which case it makes sense, yeah, exposing multiple options for, yeah, either different weights or different input files to be able to ensure that your modern system is being effectively utilized. Yeah, but yeah, even for the real world benchmark cases, I still have a handful of real applications that have problems running on more than 64 CPUs that they'll segfault or have other issues.
Mm-hmm. Again, Chad asks, and this one actually is a really good question. Thanks, Chad. So in the past years, what are the top 3 performance improvements you have seen from better compiler or kernel functionality?
The top 3. That is a very good question. I have to think about it. Hmm. One of
No
the
worries.
most
Sorry.
um
Sorry. Go
yeah, no
go ahead.
problem. One of the most significant ones has been when PCI Express Active State Power Management, or ASPM, was properly enabled for the Linux kernel. That wasn't performance per se, but power savings. That provided a very significant improvement in power reduction on Linux while not regressing the performance at all. Um, so that is one that comes to mind because at one point it had a kernel regression when I noticed like a 20-watt difference in a desktop's power consumption. Um, but in general, there has been a lot of good kernel performance optimizations over the years. Um, trying to think of like a top one or few that come to mind. But yeah, it's been mostly like a lot of little improvements over time that have really paid off. Like on the GCC or LLVM front, there's been some changes to their optimization flags that have paid off when they add a new optimization to like O2 or O3. But yeah, nothing else at the moment comes to mind for like just something so godly that it was so great for performance. Um, Maybe Intel's P-State driver back for Sandy Bridge when that got introduced. I think that did provide some notable uplift at that. For the ACPI CPU for that driver, maybe as one of the major ones.
Mm-hmm. Yeah, it's funny, it reminded me actually how well, I mean, like I used to work in compilers for like maybe four years, and then I I saw multiple times when like you woke up in the morning, and then you see, like, for example, a huge spike in performance, and then it comes from the compiler, which completely eliminated the whole kernel of the benchmark. Now essentially just returns. So and then obviously performance skyrocketed. So I mean, well, maybe the benchmark was not written properly. I agree, but just like it's funny to see those advancements in compiler technology over the years, and actually, and the same goes for CPUs as well, for example, right? Because now we also observe this this feature in Intel CPU's recent feature called immediate folding. Like again, I saw kernels where where performance just skyrocketed 3 times just because of that feature in the CPU. So yeah, it's an interesting and actually I mean, elaborating more on that topic, Mike. You are someone who actually monitors performance trend and does that for a long time. So when you just look at the scores, do you have hope that we will see get better and better?
With a few of the benchmarks that I've been running for a long time, like say the Time Linux kernel compilation. Um, Whenever I have my hands on a brand new processor, I'm always curious to see how quickly it can compile a default configuration of the Linux kernel. Like remembering back in the day when it broke like 10 minutes and 5 minutes, and then 60 seconds, and then with the very latest server processors today, now under 20 seconds. Like that's been one particularly satisfying benchmark, given how real world it is if you're a kernel developer and frequently recompiling the kernel, or just compiling large code bases often for a build farm or just debugging, regression testing, etc. But then like some of the Blender or the Videoland David AV1 decoder folks were always interested in my benchmarks early on because they were striving for being able to decode 1080 frames per second for 1080p content. So yeah, 1080 FPS for 1080p was just another good example for something that's interesting and worthwhile for benefiting end users as opposed to just some arbitrary benchmark score. But yeah, it's been very interesting, especially the past few years with the increasing core counts and AVX 512 for seeing how much the performance has changed over the years. And then occasionally when I do looking at Linux performance over the past 5 or 10 years with powering on some of the old systems for, just comparing side by side how much the improvement has been.
Yeah. Well, I am also hopeful. But just speaking about the hardware. So like, what hardware excites you the most? Is it traditional CPUs, GPUs, or maybe you are looking forward for new type of accelerators? Maybe like Bitcoin in mining and other types of hardware. So what hardware are you excited about?
Um, all of the latest AMD and Intel processors from servers to desktops have been very exciting. We're in a very competitive space right now on the CPU front. That's been terrific. And then looking ahead to this year, CPUs with larger cache sizes or HBM on die should be very interesting and providing great uplift, especially for HPC computing and other areas that can benefit from the larger CPU caches. Um, that's been something to very much look forward to and exciting. On the accelerator front, it's continuing to improve. What I'm really forward to on the front is improvements on the software stack. With GPU computing, NVIDIA's CUDA is still dominating, frankly, among software developers. But like Intel with one API and level 0 is showing a lot of hope. But in general, the past few years, it's been unfortunate that the accelerator software ecosystem really hasn't matured too much, where there is some dominant competitor to CUDA. We are seeing some possible signs with Kronos's Sickle for single source for compiling to different targets, or even their SPIR-V intermediate representation. And then lots of centralizing about LLVM. But I'm certainly hoping some great maturity in the software ecosystem that will be able to exploit all these forthcoming accelerators.
Yeah, and thank you for mentioning one API and SQL. That's that's 1 year of my life. That's what I spent at least 1 year of my life on. So yeah. Uh, so in general, I wanted to ask you, so what are the areas where you can see and you can maybe expect that we will have a breakthrough, and it applies both to hardware and software. Like, okay, you mentioned some of those already, like maybe one API, one other things, but where do you think we will have this breakthrough in the upcoming years?
Yeah, it'll be very interesting. On the hardware side, everything that all the major vendors have announced, at least on paper, sound very exciting. So it'll be interesting to see how well a lot of that hardware delivers once it's actually in production and widely available. Certainly, yeah, the larger CPU caches are going to be very interesting, and CXL for the Compute Express Link interface will provide a number of interconnectivity benefits. Then, yeah, on the software front, very interested in one API and software interfacing with the various Chrono standards. Uh, and also, yeah, the growth of LLVM the past number of years with all the major vendors pretty much centralizing around that for their compiler infrastructure. So that will hopefully mature to the point, especially with their MLIR intermediate representation and some of these other LLVM subprojects coming about, to really unify the software ecosystem so that code bases can be more portable to all these different accelerators and XPUs and just coming to market. So in generally, I'm excited about all the hardware that's coming in future generations, assuming it can deliver, and then yeah, all the open source software activity that's happening.
Are you looking for those, those loon shots, like, like for example, in-memory compute, like those new, how it's called, like a neural hardware architectures, right, and hybrid architectures, and maybe actually, are you looking forward to quantum computing?
We'll see how well quantum computing pays off. Like, I don't give it too much thought at this stage, just since I'm looking more in the shorter term. Um, Hopefully, quantum computing will be able and commercially available in the not too distant future. Um, but yeah, in general, excited about CPUs and hopeful. Like for instance, some of the recent Intel processors have offered neural accelerators, since like Tiger, like that. I haven't had any success yet really using or finding Linux distributions that are letting those accelerator packages by default. So I'll be more intrigued by those accelerators once there is broader software ecosystem support. Like, I'm still disappointed in many Linux software packages not supporting OpenCL. I would have figured 5 or 10 years ago, or yeah, 5 years ago, that OpenCL would be in better shape today than what it sadly is. Um, like GIMP and many of the others have some level of OpenCL support, but then there's also Linux distributions not even shipping OpenCL drivers by default. So most Linux desktop users aren't even having OpenCL available, or for some hardware, it's still not really integrated into the distribution, so you have to go download a separate package to have OpenCL. But at the same time, Vulkan is proving itself capable for GPU compute, so maybe moving forward, we'll see more applications embracing Vulkan for acceleration. But yeah, it's all about ensuring that the software ecosystem can keep up with all these different accelerators and coming to market.
Well, cool. Mike, so I just wanted to ask you, what are your future plans with Phoronix? Do you kind of do you maybe nurture some idea that will bring Phoronix and Phoronix benchmarking suite to the next level?
Nothing too long term. Mostly keep grinding away and benchmarking as much as possible, and just seeing where things lead. No other particular plans. Like I have been with forthcoming processors being more cloud focused. I have been looking at the capabilities for being able to run benchmarks more concurrently. Like take for instance running an Apache web server so that the Phoronix Test Suite could run multiple copies of the Apache web server to see how many instances you could scale up, each running within a container on the same hardware platform while meeting a certain minimum quality of service, like 500 requests per second or something like that, or how many video encode instances you could carry out at the same time on that server while ensuring each instance is at least like 60 FPS. So I've been like playing around with some code in that area for more concurrent or density related benchmarking in preparation for like Zen 4's processors or Ampere's cloud focus processors for doing more concurrent benchmarking and building up a framework to allow that to happen in an automated and friendly way. So that'd be just one particular thing, but yeah, just in general, continuing to monitor the open source and Linux software space.
Well, yeah, thank you. And again, I mean, I can only imagine how much hours you're putting it, you're putting in. I like I you know like I thought that I was working too much, but probably when I look at you, I realize that it's not the case. But yeah, and again, thank you for doing all of that hard work. Um, and you're probably you're on a constant lookout into many mailing lists, right? Probably including like major compilers like LLVM, GCC, Linux kernel mailing list, right? What else you're sort of tracking?
Yeah, obviously all the major compilers, the Linux kernel, and all of the various mailing lists there from like ACPI, Linux Activity to the DRI and DRM for the graphics drivers. And then a lot of the other x.org and freedesktop.org projects that are more desktop oriented, as well as the various other desktop environment mailing lists. It's mostly a collection of everything that I find personally interesting and that I find that readers enjoy reading about when I've covered it in the past.
Cool. Well, thanks, Mike. So I'm sure you're an inspiration to many folks in the industry, and I think in general, like everyone should have someone to follow, someone to learn from. And are you inspired by someone? And maybe you can tell some names.
Um, Certainly been inspired by the great job that Linus Torvalds has done on the Linux kernel and everything like that. Um, and just the whole ecosystem at large with the commitment that many have for open source software.
Oh, cool. Thanks. Yeah. Well, okay. All right, Mike. Before we let you go, do you have any recommendations for like books, maybe podcasts, blogs? Tell us, how do you educate yourself?
Just a lot of reading and monitoring of mailing lists and kernel activity, and just other Git repositories. Um, and just keep experimenting and grinding away at it.
Cool. All right, I'm actually quickly taking a look at at the Discord chat as well. This is a final for questions from the audience. If you guys want to ask Mike a question, it's now a good time to do that. Uh, uh, I'm looking at the comments section. Looks like not much comments left. All right. I guess that's all for today. Again, Mike, thank you for all the work that you have done, and congratulations on the success that you achieved already. And yeah, we looking for more good new articles on Phoronix.com. Thank you
Thank
very.
you.
Sorry. Yeah. Thanks, Mike, for being with us today. It was a pleasure talking to you.
Thanks. It was good talking to you.
All right. Thanks, guys. See you next time.
Bye.